For as long as we've had eyes to see, we've looked up at the night sky and asked the same humbling question. Are we alone? We built entire civilizations around the stars, wrote epic poems about the cosmos, and for thousands of years, all we could do was wonder. Then, we built a machine. A time machine, really. A giant golden eye designed to look back to the very dawn of creation and peek into the skies of worlds light years away. The James Webb Space Telescope was sent up there to rewrite the book on the universe, but in its search for answers, it's found something much more complicated. Something that challenges our very understanding of existence. It hasn't just found new clues, it's showing us that we might have been asking the wrong questions this whole time. The telescope's latest discoveries are forcing scientists to face a reality so unexpected. It feels like the cosmic rulebook we all thought we knew might have been wrong from page 1. Tearing up the cosmic timeline before Webb, we had a pretty neat and tidy story of the universe. It all started with the Big Bang, 13.8 billion years ago. For the first few 100 million years, the universe was in its cosmic dark ages, a vast black expanse filled with little more than hydrogen and helium gas. Slowly, gravity started doing its work, pulling that gas together and birthing the first tiny, faint stars. Over billions of years, these little star nurseries would merge and grow into the majestic galaxies we see today, like our own Milky Way. This was the standard model, the foundation of cosmology, built on decades of work from telescopes like Hubble. It was a story of slow, gradual evolution. Then, Webb opened its eye, and that story was shattered. In its very first deep field images, Webb stared at patches of sky we thought were empty, and it saw them, galaxies, but not the small, wispy baby galaxies our models predicted. It saw massive, bright, and surprisingly structured galaxies. These weren't cosmic toddlers. They looked like cosmic teenagers, already well-formed and packed with stars. The real shock came when scientists calculated their age. These galaxies weren't from a few billion years after the Big Bang. Webb was seeing galaxy candidates dating back to just 200 to 300 million years after time began. That's the cosmological equivalent of finding a fully grown oak tree just a week after you planted the acorn. The existence of these objects, which some scientists have nicknamed universe breakers, throws a huge wrench in the works. Our theories just didn't account for this. There simply wasn't enough time in the playbook for galaxies this big to show up so early. It means that whatever process turned gas into stars back then was happening at a ferocious, unbelievable rate, far more efficient than anyone had ever guessed. This has sent scientists back to the drawing board to rethink the very first chapters of cosmic history. This discovery was shocking, not just for what it showed us, but for what it meant about our own knowledge. If our understanding of how galaxies, the cradles of stars and planets, was this wrong, what else did we have wrong? The search for a second Earth, this rewriting of history, has huge implications. If galaxies got a head start, it means the heavy elements forged inside those first stars, carbon, oxygen, nitrogen, the ingredients for life, were also spread throughout the universe much sooner. The timeline for life itself might have been pushed back by billions of years, and that has supercharged one of Webb's other primary missions, the search for habitable worlds. For decades, this search was like looking for a needle in a cosmic-sized haystack. We could find planets, but knowing anything about them was tough. We needed to see if they were in the habitable zone, that perfect Goldilocks spot around a star where liquid water could exist. But even that isn't enough. A planet could be in the right place and still be a dead rock. The real prize was to study a planet's atmosphere. An atmosphere can tell you about its climate, its weather, and tantalizingly, it could hold chemical fingerprints. This is where Webb's real power shines. Using a technique called transit spectroscopy, the telescope does the seemingly impossible. As a planet passes in front of its star, a tiny bit of starlight filters through its atmosphere. Webb's instruments are so sensitive they can catch that light and break it down into a barcode of chemicals. Different gases absorb light in unique ways, and by reading that barcode, astronomers can see what's in the air of a world light years away, from water vapor to methane. And one of its targets has revealed a clue so intriguing, it's become one of the most debated topics in science today. The mystery of K2218b. Meet K218b, a planet about 8.6 times the mass of Earth, 120 light-years away. It orbits in its star's habitable zone, making it a prime target. When Webb analyzed the light from its atmosphere, it found the clear presence of both methane and carbon dioxide. That alone was huge finding. Carbon-based molecules on a habitable zone world is a major step. This discovery led to a fascinating theory. K2-18b could be a Hycean world, a hypothetical type of planet with a hydrogen-rich atmosphere and a surface completely covered by a liquid water ocean. Imagine a planet-wide ocean under a thick, gassy sky, a world totally alien to Earth, but one that could, in theory, support life in its waters. But here's where the story gets really interesting. Buried deep in the noise of the data, scientists saw something else. A whisper, a hint of a molecule that, if it's real, would be one of the most profound discoveries ever. The data showed a possible trace of dimethyl sulfide. On our planet, DMS is a substance that is overwhelmingly produced by life. Most of it comes from phytoplankton in the oceans. It's part of what gives the sea its distinct smell. Now, it is incredibly important to be clear here. The scientific community is being extremely cautious. The evidence for DMS is highly tentative and has absolutely not been confirmed. It's on the razor's edge of what Webb can even detect, and many scientists argue there's insufficient evidence to make the claim. It could very well be a fluke in the data or an error in the instruments. But the mere possibility is staggering. To even have a hint of a molecule so closely tied to biology on a distant ocean world. It doesn't prove there's life on K2-18b, but it's the most tantalizing clue we've ever had that the chemistry for life might be active on another world. The prime candidate, LHS 1140b, while the debate over K2-18b continues, Webb has turned its gaze to another, maybe even more promising, target. This world, LHS 1140b, is much closer, just 48 light-years away, and it's quickly becoming a star candidate in the search for a truly habitable planet. Based on early data, astronomers weren't sure if it was a small gas planet or a large rocky one, but new analysis, powered by Webb's precision, is painting a very different picture. The latest findings strongly suggest that LHS 1140b is not a gassy mini-Neptune after all. Instead, it appears to be a super-Earth, a rocky world like our own, just bigger, and it sits comfortably in the habitable zone of its small, cool star. That alone is exciting. But it's the potential for what's on its surface that has scientists so focused. Models based on its density point to a breathtaking possibility. LHS 1140b could be a water world. Not a Hycean world with a hydrogen sky, but a rocky planet potentially covered in a vast, deep ocean of liquid water. By many measures, it is one of the single best targets we've ever found for a world that might support life as we know it. The next step that won't happen right now is to find out if it has an atmosphere. Scientists are using Webb to stare at the planet, waiting for it to pass in front of its star, hoping to catch that filtered light. Finding any atmosphere would be a monumental discovery. But the real jackpot, what they're truly hoping to see, is a thick, nitrogen-rich atmosphere, like Earth's, would be the ultimate prize. It could provide the pressure needed to keep water liquid and shield the surface from harsh stellar radiation. Just imagine what that would mean. A rocky world, right in our cosmic neighborhood, with a global ocean and a protective, nitrogen-based sky. It's the perfect recipe, while the final evidence isn't in yet. The hunt on LHS 1140b represents the absolute cutting edge of this search. The grander narrative, when you step back and connect these dots, the truly shocking picture starts to come into focus. This isn't about one discovery, it's about a total shift in how we see the universe and our place in it. First, Webb showed us the cosmic timeline is wrong. The universe was building big, mature galaxies, the homes for planets, way faster than we thought. This means the raw materials for rocky worlds and the elements for life were available billions of years sooner than our old models predicted. The window of opportunity for life to begin may have opened almost as soon as the cosmic dark ages ended. Second, Webb is showing us that planets with the potential for oceans might not be rare. Worlds like K2-18b suggest that Hycean or ocean planets could be common, and the discovery of carbon-based molecules there confirms the building blocks of organic chemistry are present in these alien skies. Third, that faint, unconfirmed whisper of a potential biosignature on K2-18b has changed the game. It has taken the search for life out of the realm of theory and put it squarely into observational science. We are now actively hunting for measurable signs of biology on other worlds. And finally, prime candidates like LHS 1140b show us exactly where this hunt is going. We're moving beyond just finding planets in the right zip code. We're now identifying specific rocky worlds that could have Earth-like conditions, and we finally have a tool powerful enough to check. So the most shocking discovery isn't one thing. It's all of them together. It's the mounting evidence that the universe is far more hospitable to life and has been for far longer than we ever dared to believe. We thought we were looking for a needle in a haystack. Webb is hinting that the haystack itself might be made of needles. Questioning the foundations, Webb's reach extends even beyond galaxies and its observations are so precise that they're starting to test the very foundations of cosmology. For instance, in a landmark achievement, Webb worked with the Chandra X-ray Observatory to create the most detailed map ever of dark matter in a formation known as the Bullet Cluster. By studying this massive collision of two galaxy clusters, Webb traced the distribution of this invisible substance with incredible clarity. The dark matter was in clumps and structures that don't quite fit with our simpler theories of how it should behave, suggesting the collision was far more chaotic than we knew. More fundamentally, those shockingly massive early galaxies have sparked an intense debate. The standard Big Bang model is still our best theory for the universe's origin, backed by overwhelming evidence. However, some researchers argue that Webb's unexpected findings prove our models of how the first galaxies formed are deeply incomplete. To be clear, this doesn't disprove the Big Bang, but it does show that we're now in an era where our most fundamental assumptions are being stress-tested with real data, and some of them are showing cracks. So, what is the James Webb Telescope's most shocking discovery? It's not a single planet or galaxy. It's the systematic dismantling of our certainty. It's the realization that the universe is more complex, more dynamic, and frankly, weirder than we ever gave it credit for. We're seeing that the cradles of life, the galaxies, formed in a flash, not a slow crawl. We're finding that worlds with oceans and the building blocks of life might be all over the cosmos. We have prime candidates for a second Earth and are, for the first time, actually looking for signs of life in their sky. The telescope was built to help us answer the question, are we alone? But instead, it seems to be responding with something far more profound. You're not as special as you think. The conditions that led to life on Earth, a rocky planet, liquid water, the right chemistry may not be a cosmic miracle. They might just be a common cosmic outcome. The most shocking discovery is that we seem to live in a universe that is tailor-made for life. Webb has opened a new window onto the cosmos, and as we look through it, we're realizing the story of the universe isn't finished. We're just starting to read the most exciting chapters.